Hi everyone! In this series of videos, we're going to discuss the field of complex numbers. I split this lesson into several videos covering the following topics: the set of complex numbers, algebraic properties of complex numbers, the geometry of complex numbers, complex operations in exponential form, and the topology of complex numbers. So, if you're ready, halina't matuto. So let's start with the set of complex numbers. At the end of this lesson, the students are expected to be able to define the set of complex numbers and to perform basic arithmetic operation in complex numbers, addition and multiplication of complex numbers. Throughout, we are going to use the following notations: capital N for the set of natural numbers, capital C for the set of integers, capital Q for the set of rational numbers, Q prime for the set of irrational numbers, and the union of Q and Q prime, capital R for the set of real numbers. First, let's define what a complex number is. A complex number is an ordered pair xy where x and y are real numbers. So a complex number has two components. The first component, x, is called the real part of z. The second component, y, is called the imaginary part of z. We usually denote the real part as RE of z and the imaginary part as IM of z. So the set of complex numbers comprise of all those ordered pair xy where x and y are real numbers. It will be very convenient for us to denote a complex number by a point in the Cartesian plane. To differentiate the complex plane from the Cartesian plane, usually we will call the x-axis as the real axis and the y-axis as the imaginary axis. So the point xy has x coordinate on the real axis and y coordinate on the y-axis. The point x on the real axis is a pure real number, while the point y in the imaginary axis is a pure imaginary number. So how do we add and multiply complex numbers? Let's say we have the complex numbers z1 given by x1, y1 and c2 given by x2, y2. The sum z1 plus c2 of the complex numbers is given by the first component is the sum x1 plus x2, while the second component is the sum y1 plus y2. So to get the sum of two complex numbers, all you need to do is to perform component-wise addition, meaning you just add the real part of the first number with the real part of the second number, and you add the imaginary part of the first number and the imaginary part of the second number. On the other hand, the product C1 times C2 of complex numbers is given by the first component is x1, x2 minus y1, y2, while the second component is x1, y2 plus x2, y1. Now, this seems a little bit cumbersome to memorize, but it's actually easy to remember if we use Miss Floyd. Let me introduce you to Miss Floyd. F is first, while L means last. So first, you multiply the first components of the two complex numbers. So that's x1 times x2. L is for last. So you multiply the last components of the two complex numbers. So that's y1 times y2. So F minus L gives you the real part. So that's x1, x2 minus y1, y2. Now, O is outer while I is inner. So outer means x1 times y2. Because if you look at the position, then you're multiplying them, they are on the outer of the product. So that's x1, y2. On the other hand, the inner is given by y1 times x2 or x2 times y1 since multiplication is commutative. Because when you look at the product, the position is inner. So you have O, x1, y2 plus I, which is x2, y1. So the product C1 times C2 is given by F minus L for the real part and O plus I for the imaginary part. So that's x1, x2 minus y1, y2, comma, x1, y2 plus x2, y1. So again, that's Miss Floyd for you. That's actually the wife of Mr. Foyle when we're doing the binomial expansion or product of two binomials in high school algebra. Again, that's first minus last, comma, outer plus inner, Floyd. So let's have some examples. Let's say we have C1 equals negative 2, 3 and C2 equals 4, 2. Let's find the sum C1 plus C2 and the product C1 times C2. So for the complex numbers negative 2, 3, and 4, 2, to get the sum, we just have to add the real part. So we have, for the real part, negative 2 plus 4. For the imaginary part, we have 3 plus 2. So that's equal to 2, 5. Now to get the product, all we need to do is to perform Miss Floyd. Remember, Miss Floyd is first minus last for the real part, outer plus inner for the imaginary part. So we have negative 2 times 4 minus 3 times 2 for the real part, and then for the imaginary part we have outer is negative 2, 2 plus 3 times 4. That's the imaginary part. Simplifying, we have negative 8 minus 6, or that's equal to negative 14. And then for the imaginary part, we have negative 4 plus 12, or that's equal to 8. So negative 2, 3 times 4, 2 is equal to negative 14, 8. Now it's your turn. So get your pen, get your paper, and find the sum of 2, negative 1, and negative 3, 4. After that, find the product 2, negative 1 times negative 3, 4. Go ahead and pause this video and do it on your own. Okay, so did you try it on your own? So to check if your answer is correct, 2 negative 1 plus negative 3, 4 is negative 1, 3, while 2 negative 1 times negative 3, 4 is negative 2, 11. That's it. So in our next video, we're going to discuss algebraic properties of complex numbers. I hope to see you there.